On 7.3, we'll be using a hypothesis test based on a smaller sample, and by small we mean less than 30. And I'm going to be going through an example in your book on page 394, and the problem is number 20, and it's the battery life. So I'm going to focus in on that right at the moment. And if you read that problem, a company claims that the mean battery life is at least 30 hours. You suspect this claim is incorrect, and you do a study on 18 MP3 players. You find that their mean battery life is 28.5. They have a standard deviation of 1.7. Is this enough to reject this company's claim at alpha 0.01? So the first thing I'm going to do is write down the information as we have done before. And I have here what I wrote down, page 394, number 20. The claim, the battery life is at least 30 hours. And so if it's at least 30 hours, they're claiming that it's 30 hours or more. So here, my H naught is the claim. So my HA is mu less than 30. They studied 18 of these batteries. They found that their mean, so X bar, is 28.5, S 1.7, and using an alpha of 0.01. And I drew out a little sketch before I even go to my calculator, and I divided it up. Since this is a left-tailed test, I made the tail on the left-hand side. Notice I have a 2.567 there as my cutoff, and I got that by turning to the T distribution chart. Now this is located back on A18, or if you printed out your tables from D2L, you'll have this chart in the charts and formulas. Now you're going to have to deal with a degrees of freedom instead of an n value. Degrees of freedom is always n minus 1, so in this case it would be 17. I have a one-tailed test with alpha being 0.01, so I cross the 0.01 with the 17, and notice that that gives me the 2.567. So that's the number I'm using as my critical point, my critical value that I listed on my chart. All right, so that's where I got this number from. And now I'm just going to show you how to put this in on your calculator. All right, so you get your calculator out and you turn it on. Now this is going to be a t-test. So we are going to go to Stat and to Tests. So we're arrowing over to Tests, and number 2 gives us the t-test. Now we're going to be actually loading in the data, or from the statistics. We aren't using a list. If we were using a list, we'd hit the word data instead. But since they gave us the mu and the x bar and the sx, we're going to go with that. Now, right here under mu naught, that is the value from our h naught statement, which was 30 hours. That's what they were claiming. What we found was that they had 28.5 for a mean battery life. Our standard deviation was 1.7 hours. Our n value was 18, and this was a left-tailed test. So I'm going to hit enter on the left tail and then go down and have it calculate. And here I've got a t value of a negative 3.74. My p value is 8.08786, but notice that's e to the negative 4. So that means I move this over 4 places. So the p-value is actually 0.0008. Very small p-value. So now we're going to go back and we're going to look at this in context of what we have written here. Now, if you looked at that t-distribution chart, notice that everything is positive. When you are dealing with a left-tailed test, it's just assumed that you're going to know that everything to the left is going to be negative. So your critical value is actually a negative 2.567. I'm going to compare that to what I found on my calculator, which was a t of a negative 3.7435. And notice that that lands in the HA zone. So negative 3.74 is down in this vicinity. So that means that we are going to be rejecting the null. Since it's in the rejection zone, we reject the null. We're rejecting this claim. So we are not supporting their claim that it is greater than or equal to 30. Our evidence is pointing to the fact that it is less than 30 according to our study.